All right, so in the last section we talked about the law of sines. When can you use the law of sines? What do you have to have in order for the law of sines to work? What? What do you mean 1 and 1? 1, 2, 1. No, it has nothing to do with 1, 2, 1. You have to have a pair. A pair of what? You have to have like a big B and a little b, or a big C and a little c. You have to have a pair. Okay, you have to have a match. When you don't have a match, you're going to use the law of cosines. So if you know side A and side B, but angle C, that's a law of cosines problem. When things don't match, that's a law of cosines. All right, so I'm not gonna derive the law of cosines for you. I'm just going to ask you to believe me that this is true. If you want to see where it comes from, you can look it up in your book. It's really just a special case of the distance formula. All right, but here's the law of cosines. There's actually 3 of them. C squared equals A squared plus B squared. That looks familiar so far, right? What's that? When does the Pythagorean theorem work? If you have a right triangle. If you don't have a right triangle, you got to have a little correction. Minus 2AB cosine C. So that's the first law of cosines. Now, what if I did have a right triangle? What if C was a 90-degree angle? What's the cosine of 90 degrees? Not 1. It's 0. The cosine of 90 degrees is 0. So if I have a right triangle, cosine of 90 degrees is going to be 0. All this part's going to go away. And you do have just the Pythagorean theorem. All right. The other 2 law of cosines look like this. A squared equals B squared plus C squared minus 2BC cosine A. So what happened? All I did is permeate the letters around. And then the last one is B squared equals, what would B squared equal? A squared plus C squared to AC cosine of B. All right, so once you know one of them, once you know C squared equals A squared plus B squared minus 2AB cosine C, the other 2 are just rotate the letters around. So it's not that hard to remember all 3 of them. All right, so here's where you would use the law of cosines. We'll make up a triangle here. We'll call this angle A, and this will be side A. Angle B, side B. Angle C, side C. All right, so let's make up some numbers here. Side A, 12. Excellent. Side C. Well, side C looks longer. But it doesn't look that much longer. 15. And how about angle B? That doesn't look like 10 degrees.
30.
I'm thinking more like 60 or 70 degrees, yeah.
Oh, the degrees.
Yeah, 65 degrees. 65 degrees. Angle B. All right. And again, the directions are usually solve the triangle. Do we have a pair?
No.
No, we don't. We have little a, little c, and big B. If I have little a, little c, and big B, what can I find? I can find b squared, little b squared, which of course means I can do square root and find little b. If I know a, c, and big B, I can find little b. So that's what we'll do. B squared is 12 squared plus 15 squared minus 2 times 12 times 15 cosine 65 degrees. Yeah, we'll get to that in just a minute. Yeah, good. All right, so I grab my calculator. What's that? 65 degrees. I think I better make sure I'm in degrees. Yeah, typically we work in degrees here with law of sines and law of cosines. 15 squared. minus 2 times 12 times 15 cosine 65. I get b squared is about 216.86, and I take the square root of that number, and I think I'll round to one decimal place. B is 14.7. So now I know B. Not so bad so far, but of course we're not done.
Yeah.
But now I have a pair. Now I have a little b and a big B. So now I can use what? Now I can use the law of sines to find, I guess I'll find big A. So now I can use sine A divided by little a is 12 equals sine 65 degrees divided by 14.7. The only bad part about this, and we don't have a choice, we have to use the 14.7. We have to use something we calculated. That's not great. Why not?
Because if you got that wrong, then all your answers.
If I got that wrong, then everything else is going to be wrong too. But there's no other choice. We avoid that whenever we can, but in this case we can't avoid it. We got to use that number, so we use it. We hope we didn't screw up from the beginning, because then everything else is going to be wrong, and it's a real pain in the neck. But we live with it and see what happens. All right. So sine A is, I'm just going to do the arithmetic here on my calculator. 12 sine 65 divided by 14.7. That's about 0.74. And I do sine inverse of that number. And when I'm doing sine inverse here, I'm not rounding off. I'm using the whole number on my calculator. I get A is about 47.7 degrees. I multiplied by 12, so I did 12 times sine 65, and then divided by the 14.7. And that gave me sine of A is 0.74, so then I had to use my sine inverse button. Yeah, you can do it all at once too if you want. That works. All right, how am I going to find C? Same way I could. That's too hard. I could do 180 minus 65 minus 47.7, and that's how I find sine C. Once you have two angles, finding the third one is easy. So C is 180 minus the 65 minus the 14.7. Oh, not 14.7. 47.7. 67.3 degrees.
Oh, I did the sine because I just was really stupid. You're at 67.6, so I just rounded.
All right, yeah. That's something that can be a problem with these, actually. What she just said is she did the law of sines and worked it out to get C and got 67.7. 67.6, which is pretty far off, really, if you think about it. You can get pretty big round-off errors with these, which is kind of weird. So you want to keep, notice when I used my calculator, I said 0.74, but I kept all the digits, and then I did sine inverse of that answer. You want to keep as many digits as you can for as long as you can. And you
So would that be wrong if I did not have a test? Even though I should.
if you did it on the test and showed your work, you would be fine.
Oh.
What I'm warning you about is if you do it on WebAssign, WebAssign might not be so friendly.
Okay.
So if you run into issues with that with WebAssign, send me a note, let me know, and I can go in and fix it later. All right, other questions on that? Does it get harder? I don't think so.
No.
I got one more problem for you. And then I'm going to give you some problems, and you'll
Oh, I know.
find out if it's harder.
I did the
What if I give you three sides? A is 5, B is 6, C is 9. I could draw the triangle first, yep. Not really need to. How can I find an angle? I can't use Pythagorean theorem. All right,
Plug
so
everything in.
which formula?
Uh,
Which one of the law of cosines?
First one.
Doesn't matter, all right? It doesn't matter. C squared equals A squared plus B squared minus 2AB cosine C. I know little a, little b, little c. I'm going to plug all those things in, and I'll have to do some algebra to figure out cosine C. So 81 equals 25 plus 36 minus 2 times a, that's 2 times 5, that's 10. 10 times 6 is 60 cosine C. So it's mostly a calculator problem at this point. 81 minus 25 minus 36. I get 20 equals minus 60 cosine C. So negative 1/3 equals cosine C. Use the cosine inverse button on my calculator. Cosine inverse of negative 1/3. Calculator says that's 109.5 degrees. Now what? I could draw the triangle. I don't need to. I really have two choices. I could do law of cosines again with either cosine A or cosine B over here. Or, again, my choice is I now have a big C and a little c. I have a pair. I would prefer on this problem to use the law of cosines again because this is a number we figured out. So while the law of sines is probably a little bit easier, personally I would probably do a squared equals b squared plus c squared minus 2bc cosine a. I would actually use the law of cosines twice. Just because, again, I can use little a, little b, little c. Those were all given numbers. I don't have to use something I figured out. That's my opinion. We should avoid using stuff we figured out whenever we can. All right, so it's not terribly hard is the good news. 25 equals 36 plus 81 minus, oh, I'm not sure if I can do 2 times b times c in my head. Let's see. How much? 108. I guess some of us can do it in our head. Cosine. No, we used our calculator. All right, that's good. Yeah, you impressed me for a minute there. Blew it. All right, so 25 minus 36 minus 81. Oops. I can push the minus button, not the plus button. Negative 92 equals negative 108 cosine A. Divide, do the cosine inverse thing. A is I get 31.6 degrees. And then to find B, well, I would do 180 minus that one. I wouldn't do the law of cosines again. I'm going to take my chances that I did okay there. 180 minus 109.5 minus 31.6. 38.9. Questions?